It's important to have a resistor in a circuit because without that resistor, so with that hole, my charges don't have a complete pathway and they won't flow. This is again considered an open circuit. If I were to close that gap by pulling the two pieces together, you see right away that my simulation here shows a fire. This represents that there is an overload of the circuit. So if I increase my voltage, then it's going to affect the speed at which my charges move, or the current. So by increasing my voltage, I increase the current. What we have is a direct relationship. My resistance is staying constant because I'm using the same light bulb in the circuit. Over here, we have what is considered a parallel circuit. A parallel circuit is notated by having multiple pathways, which means that if I trace my charges, they leave the battery, they make this turn, and now my charges have two options. They can either continue to move up, or they can move across. So by choosing a pathway, that's going to allow for each path to have a little bit less resistance. In a parallel circuit, the voltage across each branch is constant. A voltmeter has a positive and a negative probe. If I check my battery, I can see that I have 12 volts leaving my battery. If I come up and I check how much voltage I have in this branch, 12 volts. If I check the voltage in this branch, it's still 12 volts. But you'll notice if you try to track a couple of these little charges that, again, some of them are moving up, some are moving over. So some of my current is going to move this direction, and some of my current is going to move this direction. So now it doesn't really matter how many light bulbs I add in a parallel circuit, because the resistance in a parallel circuit is actually going to decrease over time. By creating more pathways for my charges to go, I can decrease that current a little bit more, a little bit more, a little bit more, which is going to alleviate some of those resistance issues. So as we add a branch, if I were to add something in here, and I think about this as being like a highway with cars, by adding an extra road, now I've created another pathway for my cars or my charges to travel along, which takes away some of the burden on the others. So my resistance decreases to allow for the current to move in more different areas. So the more we add, the more our resistance drops, because we're creating more pathways for those charges to use to get around. If I made one of my light bulbs a much stronger resistor, then you notice right away that these charges are going to be moving pretty quickly. These charges are going to slow down. So I'm going to get more current through here, and I'll get less current moving through here because I've got a higher resistance, and here I have a lower resistance. I could use something like an ammeter to measure the current. I can see that this is letting about 1.4 amps leave the battery. And if I trace it, I still have about 1.4 everywhere until I get here. Now I see a split. Some of that current is moving up here, and the rest of it is moving here. So this gets 1.2 amps, and this gets 0.2 amps. Because this has a higher resistance, it's getting a lot less current. Now if I take and put my light bulb back, now I'm going to see if I track it. I've got 1.2 here, got 1.2 here, and I have a total of 2.4 leaving my battery. So over here we have what we consider a series circuit to be. So if we look for some patterns in a series circuit, you'll notice the bulbs themselves are a little bit dimmer. And this happens because I have a single pathway for my charges to travel. If I were to trace, this is my path. So series is a single path. If I were to come over and measure my current over here on this single pathway, I'm going to notice that everywhere I go, it stays the same. Because there's just only a single pathway for my charges to travel, my current is now going to be constant. And if I use my voltmeter to measure, I can see that I have 12 volts leaving my battery. Six of those volts are going to use to push the charges through my light bulb, which means 6 more volts will be used to push my charges through the light bulb. As we saw with our parallel circuit, there is a relationship to the resistance. So if I increase the amount of resistance in my light bulb, it's going to take more voltage to get those charges to go through. And then you'll see that this one got a little bit brighter, and this one, now we can barely see the lines representing the light. It got a little bit dimmer. So we still have that direct relationship between voltage and resistance.